Okay, so taking a look in Math Excel, and this is number 8, and so again, this is where I'm referring to that if you look in the corner, if you're stuck on something in the computer, it'll tell you it's like number 33 in section 2.1 here. But it says determine if the given set is the empty set. And so for this one, it has braces with nothing in between. So is this the empty set or not the empty set? Okay, so we got choice 1 and choice 2. So we see the majority says it's the empty set. Well done. And then you could see that, you may get a different question each time you do this. If I hit similar exercise, now it gives me this one. Okay, so does this symbol mean the empty set or not the empty set? Okay, still choice 1, right? It's still this symbol still means empty set. Okay, and then you hit it again, it gives you a different problem. Okay, so even if you ask me to show a question in Math Excel, it may not be exactly like what you were working on in there. So that's one of the other reasons why I like answering questions out of the book, because then that's the same for everybody. So, okay, so now we have choice 1, this is not the empty set. Choice 2, this is the empty set. Okay, so I see the majority say it's not the empty set, and that is correct. Well done. So this time it's a set of braces, and it actually has items inside of those braces. So once you put braces around these symbols, then they become elements, and it's no longer empty. Okay, so last time we went through a lot of vocabulary on what a set is and what elements are and how we can write these in a lot of different ways. And so now we want to talk a little bit more about sets in general, maybe from a visual standpoint, and as well as how we can look at sets within other sets and how we can combine sets. And so a universal set, which we're going to symbolize by the letter U, is a set that contains all the elements being considered in a given discussion or problem. So describe a universal set that includes all elements in sets A and B. So set A is Jeopardy, Who Wants to Be a Millionaire, and set B is Wheel of Fortune, Hollywood Squares. So who can raise their hand and give me a description of a universal set that might include all of these items? Good job, game shows. Okay, so that's the answer that I had. There could have been more than one answer, but game shows does represent a set that includes all 4 of these elements in both sets. So set A and set B are inside of the universal set. Venn diagrams are used to show the visual relationship among sets. The universal set is represented by the region inside a rectangle. Now on your handout, you have the rectangle. You don't have this text that I'm showing you off to the right. That's just describing what you see in the picture. And then eventually you'll find that fill in the blank that's going to come to the right of the rectangle there. So typically we use a rectangle for the biggest set, the universal set. And then sets within the universal set are depicted by circles, ovals, or other shapes. So now I've drawn another circle inside of there, and I've labeled it with an A. So I've drawn set A inside of there. Okay, and then here's your fill in the blank. The complement of A, symbolized by A apostrophe, is the set of all elements in the universal set that are not in A. So if you see an apostrophe after the letter, it doesn't want you to say what's inside of A. It wants you to describe what's inside of the complement. In other words, what's not inside of A, everything else. So if you want like a visual of what would be a complement, So everything that just got shaded in black is the complement of A. Everything inside that white circle belongs to A. So it's almost like the opposite of A is another way that you can look at it. Okay, let's say that the universal set is A, B, C, D, E. We need set A inside of our rectangle represented by A and D, and we want to find A complement. There's a couple ways that we can do this. Now, I think you have these sets written on your handout already, right? Is that right? Okay, you could just use the blank Venn diagram that you have on your paper, and we can create a Venn diagram of all of these elements. What that means is we're going to write the letters in the appropriate spot to represent where they belong. Now, whenever you're creating a Venn diagram, you always want to start from the inside and work your way out. So the innermost part of this Venn diagram is what's inside of A. So what elements belong to A? A and D. Okay, so once we've written them inside of A, notice that not only are they inside the circle, but they're inside the rectangle. So we have written them inside of A, and they're also in the universal set. So when I do my Venn diagram, you know, I cross out the elements that I've already written, but I cross them out of the universal set as well, because I've taken care of that. Okay, so now inside the universal set, all I have left are B, C, and E. So those need to go somewhere inside the rectangle, but not inside the circle. And it doesn't matter where in that rectangle you write them. So we've just made a Venn diagram to represent these sets here. So if you recall from the last illustration that A complement was that black shading outside of A. So which elements belong to A complement? B, C, and E. Okay, so you would say A apostrophe or A complement equals the set B, C, E. Now, I didn't necessarily have to do a Venn diagram to come up with my answers. If you even just look at the red marks that I've made up there, if I just crossed out from the universal set the elements that belong to A, then anything that's left over in U is your answer. So if you're ever finding a complement, you're eliminating the items from the actual set, from U, and anything that's left is your complement. You do want to be able to make sure you recognize from both just written sets and a Venn diagram, because sometimes they'll only give you the picture of the Venn diagram. They won't give you the sets that were written up here. You have to start from the picture and identify the complement. So you want to be familiar with, you know, both of those strategies there. Okay, set A is a subset of B if every element in set A is also an element in set B. And this is how we would write it symbolically. That elongated C with a line under it, those are the words subset of. So A is a subset of B is how you would say that. So the symbol itself was one of your fill-in-the-blanks, if you didn't catch that. Notice that that symbol sort of looks like a less than or equal to symbol. It's just curved instead of pointed. In a way, you can look at it as a less than or equal to, because A is either going to be smaller than B or equal to B, because anything inside of A has to fit inside of B. So if A was bigger, there would definitely be elements that didn't fit inside of B. Okay, so that's one way you can sort of make sure you're looking at the right symbol and the right order of your sets. And then so anything listed there has to be in the second set. So here's an example. Let's say that set A was 1 and 5, the set of 1 and 5, and set B is the set of 1, 3, 5, 7. Notice that everything in the first set is also listed in the second set. So therefore, it is a subset. Now suppose that A was 2, the set of 2, 5, and B was still the set of 1, 3, 5, 7. Is everything that's in A also in B? No. Okay, so this time A would not be a subset of B. And as you saw in the last section, the way you say not something is you just put a slash through the symbol. So the same subset symbol with a slash through it means not a subset. So your next fill in the blank was that little symbol. And then we're going to skip the next fill in the blank for just one moment and go down to the next one. Set A is a proper subset of B if set A is a subset of B and A is not equal to B. So in other words, it's a subset if everything shows up in the second set, right? But it's specifically a proper subset if it has less elements in the first set. As long as it's not the set that it's equal to, it's proper. So going back up to that last fill in the blank, that's what the symbol looks like. So what's the difference between this symbol and the subset symbol? The line underneath. And as you guys are familiar with the inequality symbols, the line underneath means equal to. And so in the other one, it's a subset and it could be equal to it. In this one, it's a subset that can't be equal to the second set. So that same first example that I gave you, not only is A subset, but it was also a proper subset because there were less elements in A than in the second one. It was not the same exact set. So let's say that I introduce the set C. Okay, notice that C has the elements 1, 3, 5, 7. And so C is a subset of B because everything in the first set is also in the second set. But it's not a proper subset because it's equal to B. Okay, and again, if you relate it to that less than or equal to, then the proper subset symbol would be like a less than symbol. So it has to be less than, cannot be equal to. Has to have less elements. Yes? You also write it the other way, B is a subset of C? You could, yes. That would be, so the question was, can you reverse these letters and say that B is a subset of C? And yes, that would be acceptable because everything in B is also in C. But then what if I wrote this? Okay, so B is a subset of A is not true because everything in B is not also in A. So order is very important when you're looking at these. So I would put a slash through there to make that true. Okay, B is not a subset. Question?
So what if it's like A is 1, 5, and 8?
Okay, so if A is 1, 5, and 8, then A no longer becomes a subset of either of these. Everything in the first set has to be in the second set. Okay? All right, so facts about subsets. So first of all, every set is a subset of itself. We just demonstrated that with B and the C that I wrote there. So the empty set is a subset of every set. This one's a little harder to wrap your mind around. But if you consider, here's the empty set, and let's say that we have the set of 1, 2. So instead of saying that everything in the first set is in the second set, how about we put it this way? Is there anything that's in the first set that's not in the second set? And it doesn't break that rule because there's nothing new introduced in the empty set. There are no new elements represented there that aren't already in the second one. So therefore, it is a subset. It's sort of like a technicality. It's in on a technicality, okay, because it doesn't have any elements in there that don't belong to the second set. So therefore, it's a subset. And then does the empty set have less elements than the other set? Yeah, the empty set doesn't have any elements, right? And the other one has 2. So therefore, the empty set is a proper subset of every set except itself. So not only is the empty set a subset of every set, it's also a proper subset of every set except itself. So if you're comparing the empty set to the empty set, well, this one we have to use the proper this regular subset symbol. But this other example, I could change this to just a proper subset symbol, and that would still be true. Okay, so it's proper to every set except itself because these two are equal. The number of subsets of a set with n elements is 2 to the n. So this is a formula, 2 raised to the n power, where n is the number of elements inside. So if you had to figure out how many subsets you could create from another set, let's take a look at this set of 1, 2. So how many elements are in that set? 2 elements. So if we had to figure out how many subsets are in there, then 2 squared would be our formula, how we could figure that out. And 2 squared equals 4. Okay, so there are 4 subsets. So one of the subsets is the set itself, the set of 1, 2. But we could also have the set of the number 1. That's a subset of that one, right? Because everything in 1 is also in the set 1, 2. We could also have the set of the number 2. So there's another subset. And then there's one more subset, the empty set, right? Because the empty set is a subset of every set. So there are the 4 subsets of the original set 1, 2. So if there had been 3 elements in the set, how many subsets would there have been? 8? Is that what you said? Yes, that's correct. Good, because you would do 2 to the third power, and 2 to the third is 8. So if you just need to know how many subsets are going to be there, then you use the formula. If they want to actually know what all the subsets are, then you have to list them out like this. But the formula is helpful because you'll know how many you're supposed to make, and so therefore you'll know if you come up short and you're missing any. All right, so how many of these are proper subsets? Nope, more than that. So of these 4 sets that we wrote, 3 are, because which one's not a proper subset? The empty set is proper. The first one, right. The original set is not proper because it's equal to the set. Remember, a proper subset is any subset that is not equal to the original set. It has to have less elements than the original. And so if you needed to know how many proper subsets there are, then all you have to do is take the 2 to the n and subtract 1. You're going to always subtract the original set from your amount. So there are 3 proper subsets when there are 2 elements in the set. Okay, so going to 2.2, and notice this was, if I go back to that homework list, notice this was the last section that's covered in quiz 1. Okay, so we've covered all of the material now that's in that quiz. And the first type of question wants you to fill in the appropriate symbols. So this is just trying to make sure that you understand all the new symbols that are introduced here. So you have the set 315 blank, the set 1, 2, ... 6. So the question is, do you use the first choice of symbol or the second choice for your symbol? Excellent. Okay, so for this one, don't forget that the ellipsis in there means that You're following the pattern 1, 2, so 3, 4, and 5 are also in that set. So this is also, so this is really the set of 1, 2, 3, 4, 5, 6. And so now that you're visually seeing all the elements, you can now see that all the 3 elements in the first set are also in the second set. So that is a subset of the second one. Okay, so this time you have 4 choices. And the first set is the set of all elements X such that X is a person living in Massachusetts. And the second set is the set of all elements Y such that Y is a person living in a state with a border on the Atlantic Ocean. Okay, so you have to know a little bit about geography for this one. So you have some choices here. You can pick that it's only a proper subset. That's choice 1. Choice 2 is that it's only a subset. Choice 3 is that it could be a subset and a proper subset. Or choice 4, none of the above. So the first set is everybody living in Massachusetts, and the second set is everybody living in a state with a border on the Atlantic Ocean. So do you want choice 1, 2, 3, or 4? I think I have a majority of choice 2. Sorry, and it gives you a little explanation. Now, I can say that yes, the first set is a subset of the second one, but those of you that said choice 3, you had the better answer. Excellent, because not only is it a subset, it's also a proper subset. So there are less people living in Massachusetts than there are in every state that have a border to the Atlantic coast. Okay, so if it's not equal to it, the only time that the answer would be only a subset is if the 2 sets were equal. That's the only time that you would choose the second one. If it's a subset, then it's also going to be a proper subset unless they're equal. Now, it's very unlikely that you would choose the first choice, only a proper subset, because if it's a proper subset, then it's also automatically a subset. So really the first choice doesn't come without the third, having both symbols. If that'll help you to get through some of these questions. Any questions on that? Because I know I had a lot of mixed answers on that one. Okay, so here you have the set of all elements X such that X is an element of the natural numbers and X is between 5 and 9. Remember that that's the easiest way to say that. Or you could say 5 is less than X is less than 9. And then it says the set of all natural numbers between 5 and 9. And these are the same choices, by the way, down here. Let me scroll down. Okay, so you have choice 1, choice 2, choice 3, and choice 4. I see a majority of choice 2. Fantastic. Okay, so most of you guys answered this, and notice that these 2 sets are exactly the same. So the first, they're both the set of natural numbers between 5 and 9. And if you need to, because maybe it won't be as straightforward written as this way, you can always change the set builder notation to roster form. So this would be 6, 7, 8. And then over here, okay, this is 6, 7, 8. If you need to do that to the sets to actually list out what elements you're looking at, then feel free to do that. So because these sets are exactly the same, definitely a subset. Everything in the first one is also in the second one, but that's it. It's not proper because it has the same amount of elements. It's equal to it. Okay, so here you have the set of all elements X such that X is an element of the natural numbers and X is between 5 and 9, so that's the same one as before. And then on the right, what does that symbol mean? Empty. Okay, so you've got choice 1, choice 2, choice 3, or choice 4. most of which are answering choice 4, and I have some deer in the headlights looks that haven't answered. Okay, good job. It is choice 4 because the order is very important, remember. Everything in the first set that's listed has to be in the second set. And since there's nothing in the second set, well then no, it's not a subset of that one. Now, if it had been reversed, because I know that's what a lot of the looks were, like, I know we said something about empty set. If the empty set had been the one that was listed first, then it would have been both a subset and a proper subset. Okay. All right, then the other types of questions you're going to have are they want to make sure that you understand notation. And so they'll show you the actual sets with the symbols, and you need to determine whether this is true or false. Okay, so you have the set of 3 is a subset of the set 6, 5, 4, 3. So we've got true is your first choice, false is your second choice. So I have a majority of true. Excellent. Okay, so here you have 5 as a subset of the set 6, 7, 8, 5. So true is your first choice, false is your second choice. Okay, the majority of you guys are showing true. Sorry, that's not correct. Notice you only had 2 choices, so you're marked wrong right away on this. Why? Why is this false? Not chronological. The order doesn't matter, but you guys are like sort of motioning without. Okay, the 5 doesn't have braces around it, and so therefore 5's not a set. So it's a trick question here, and this is what some of the questions are. It has to be a set in set form in order to be a subset. So there's a couple ways that you can correct this. Now, the cop-out way to correct any of these answers is to do what? Well, you could, but what the cop-out way is to just go like this. Okay. All right, so now it's a true statement. But yes, the proper way to fix this would be to put braces around the 5, and then it would be a true statement. Okay, so if you see this question right here, is that true or false? What does that symbol in the middle mean? Element of. And so this is technically false, because this time 5 should not be in braces. Okay, because the set of 5 is not an element. There's not a set listed inside of here that has, the 5 in it. It's just the number 5 that's listed inside of here. So this one is false. This would be the correct way to write this. Okay, so 5 is an element of 6, 5, 8, 7 with no braces around it. Or that's how I could correct this. That's another way to correct this, is by placing an element symbol in there. Yeah. Right, it's just listed in there. Now, let me go back to that one that said, oh, wait, I'm not ready to see that one. Okay, so now if I show you this one, the set of 2 is an element of the set 2 and set 5. I'm sorry, 10. I don't know why I said 5. Okay. Okay, so for this one is true. Well done. Okay, because this time you actually do have sets listed inside of sets. So that exact symbol is found inside of the set. So that's, just the difference between those 2 problems. Again, it's going to be very tricky when you look at these. You just want to make sure that they're using the right symbols and the way it's written is listed in there and so on. And then the other types of questions you're going to see have to do with the number of subsets are actually identifying subsets. Okay, so here you have a set of the letters B, J, Z, and you have to determine what all the subsets are. Now, one of the things that you could do first is figure out how many subsets there should be in the first place. So how many elements are in the set? 3. Okay, so you have n equals 3. What's the formula to figure out how many subsets there should be? 2 to the n. Remember, that's an exponent. So we should have 8 subsets. All right, so if you need to, you can list these without looking at your choices, because maybe looking at the choices sort of like, it just sort of blends into the other. But the original set is always a subset. And then what I like to do is I start with the original, and then I go down 1 element. So now I'm going to do 2 elements at a time instead of 3. So I can have BJ, I can have Z with Z. Let me cross that. Okay. By the way, I cross my Z's because my Z's look too much like 2's, so you guys can see the difference. And then I can also have J and Z. So that's all the ways I can do 2 letters at a time. So now I'll do 1 letter at a time, so I can have a B, a J, and a Z. So that's all the ways I can do 1 letter at a time. Am I missing anything? The empty set. So the empty set is a subset of every set. So how many sets do I have altogether listed? 8, so I have them all. So looking for your choice, okay, C is the one that matches. If you counted, you could probably eliminate all of the choices but 1, possibly. It just depends. Maybe they'll trick you and throw in some other item in there. Okay, let's see if we're right. C, nice work. Okay, so this one doesn't want you to list the actual subsets. It just wants you to calculate the number of subsets. So what do you do first? Okay, count the elements. How many are there? 4. And then I heard formula. So here's your formula. So 2 to the 4th equals 16. Okay, as there are more elements in there, calculator could be handy in there, you know, whatever you might need. All right, so there are 16 subsets. And then how many proper subsets? 15, good, because remember, all you have to do is subtract 1 from the number of subsets. Excellent. Okay, and then the trickier type problems are wanting you to figure out if you can identify, you know, these little general statements that they give you. So if B is a subset of A and D is an element of B, then B is an element of A. So you have 2 choices. You can say, yes, that's true, or you can say, no, that's false, and they give you a way that you would correct that statement if it's false. Okay, so is it choice 1 or choice 2? Okay, the majority of you guys are saying that this is true. Good job. Okay, because remember that everything in B is also in A. And so therefore, if you pick a random item out of B, then that means that item also has to be a part of A. Now, the correction that they made down here, this is false. if B is a subset of A and you just randomly pick an element from A, that's not necessarily a guarantee that you have picked something from B. Okay, and if you need to, make actual concrete examples. You know, just do something like this. Okay, let's say that B is the set of 1, 2, 3, and A is the set of 1, 2, 3, 4. So if I pick any element in B, 1, 2, or 3, is it also an A? If I pick anything from here, is it also in this set? Yes. Okay, but is it a guarantee that I pick something from A and it's also going to be in B? No, because I could pick the number 4 and that's not going to be over here. So that's why this statement is definitely false down here, because you can't guarantee that. It's a possibility, but it's not a guarantee for every element. So you're going to have a few statements thrown at you that are just sort of general, and they might actually even give you concrete sets for you to determine your answers.